Welcome to Understanding the Sympathetic and Parasympathetic Nervous Systems. Our body is like a complex machine, and just like any machine, it needs a control system to manage its functions. That's where the nervous system comes in. It's like the body's control center, making sure everything runs smoothly. Within this system, there are two important parts: the sympathetic and the parasympathetic nervous systems. They work together, yet they have different roles. Let's first look at the sympathetic nervous system. Think of the sympathetic nervous system as the fight or flight system. When you get scared, excited, or need to react quickly, this system jumps into action. It's like a superhero, getting you ready for action. Here's how it works. When something intense happens, like if you suddenly see a scary dog, your sympathetic nervous system rushes to help. It tells your heart to beat faster, making your blood pump quickly to your muscles so you can run away or defend yourself. It also makes you breathe faster to get more oxygen into your body, giving you the energy to react quickly. Pathway of sympathetic activation. Brain signals. It all starts in the brain, particularly the hypothalamus. When it perceives a threat or stress, it sends signals to the sympathetic nervous system. Sympathetic chain ganglia. These are a series of nerve bundles located alongside the spine. When the signals reach these ganglia, they cause the release of a neurotransmitter called noradrenaline, also known as norepinephrine. Adrenal gland activation. Additionally, the sympathetic nervous system prompts the adrenal glands, located on top of the kidneys, to release adrenaline, epinephrine, and noradrenaline directly into the bloodstream. Target organs and responses. Once these neurotransmitters are released, they travel to various target organs throughout the body. They bind to specific receptors, called adrenergic receptors, on organs like the heart, blood vessels, lungs, and other vital structures. Effects of sympathetic activation. Increased heart rate and blood pressure. Noradrenaline and adrenaline cause the heart to beat faster and stronger, increasing blood flow and oxygen delivery to muscles and vital organs. Dilation of pupils. To improve vision and peripheral awareness, the pupils dilate, allowing more light to enter the eyes. Dilation of airways. Breathing passages widen, allowing for more air intake, boosting oxygen supply to the lungs. Decreased digestive activity. Blood is redirected away from the digestive organs, reducing digestive activities. This conservation of energy is vital during fight or flight situations. Release of glucose. Adrenaline prompts the liver to release stored glucose, providing quick energy for muscles to respond to the stressful situation. Sweat production. The SNS triggers sweat glands to produce sweat, helping regulate body temperature during increased physical activity. Pathophysiological conditions. Dysautonomia. This condition refers to a dysfunction of the autonomic nervous system, which includes the sympathetic nervous system. It can lead to symptoms such as abnormal heart rate, blood pressure changes, and altered responses to stress. Hypertension. Prolonged activation of the sympathetic nervous system can contribute to high blood pressure due to continuous constriction of blood vessels. Now, let's look at the parasympathetic nervous system. The parasympathetic nervous system is like the opposite of the sympathetic system. Instead of getting you ready for action, it helps you calm down and relax. You can think of it as the rest and digest system. When the scary dog is gone and you're safe, the parasympathetic system takes over. It slows down your heart rate, helps you breathe normally again, and helps your body relax. This is the time when your body can focus on digesting food and storing energy for later. Pathway of parasympathetic activation. Brain signals. Similar to the sympathetic system, the parasympathetic system starts in the brain. Specifically, the signals originate from the cranial nerves and the sacral region of the spinal cord. Vagus nerve. The most prominent cranial nerve involved in the PNS is the vagus nerve, otherwise known as cranial nerve 10. It extends from the brainstem to various organs in the chest and abdomen. Acetylcholine release. Unlike the sympathetic system, which primarily uses noradrenaline and adrenaline, the parasympathetic system primarily uses the neurotransmitter acetylcholine. Target organs and responses. Acetylcholine released by parasympathetic nerves binds to specific receptors, known as cholinergic receptors, in target organs such as the heart, digestive system, and glands. Effects of parasympathetic activation. Decreased heart rate. Parasympathetic activation slows down the heart rate, promoting relaxation and conserving energy. Stimulation of digestive activities. The PNS stimulates digestive glands, increasing saliva production, promoting stomach acid secretion, and enhancing digestive processes. Constriction of pupils. In contrast to the sympathetic system, the PNS causes the pupils to constrict, aiding in near vision and focusing. Bronchoconstriction. Airways may constrict slightly under parasympathetic influence, regulating air intake in non-stressful situations. Promotion of urination and defecation. The PNS promotes bladder contraction for urination and helps with bowel movements by stimulating digestive muscles. Relaxation response. Overall, the parasympathetic system induces a relaxation response, aiding in the recovery and conservation of energy. Pathophysiological conditions. Dysautonomia. Similar to the sympathetic system, dysautonomia can affect the parasympathetic system, leading to symptoms such as abnormal heart rate, digestive issues, and impaired bodily functions. Bradyarrhythmias. Conditions causing excessive parasympathetic influence can lead to bradyarrhythmias, characterized by an abnormally slow heart rate. Differences and similarities. While they have different roles, the sympathetic and parasympathetic systems work together to keep your body balanced. They are like two sides of the same coin. The sympathetic system gets you all revved up for action, while the parasympathetic system helps you calm down and relax afterward. They both help your body handle different situations, keeping you safe and healthy. In the end, the sympathetic and parasympathetic nervous systems are essential parts of our body's control center. They might have different jobs, but together, they ensure our body functions properly, helping us react when needed and then calming us down afterward. Understanding how these systems work can help us take care of our bodies better. Just like a good team, these systems work in harmony to keep us going strong. If you like these videos and you would like to see more, don't forget to like and subscribe.